Today we're going to talk about inverse, find the inverse values, what it means, and how to do the composition of inverse. So if you would with me, we're going to draw just a plain old sine curve. Plain old sine curve, just like that. That's not a real good one. I'm going to see if I can do better. Ooh, that's better. It's really good. All right, so then I'm going to clone it. And then I'm going to turn it 90 degrees. And then I'm going to flip it over the up and down. And what my goal is, there's where it was. And did I do that right? I flipped it. Here we go. There we go. It slid on me a little bit. So do you see a kind of a, looks like a symmetry going through there? Do you kind of see that? Like the bug? It looks like a symmetrical bug. This half looks like this half. Okay? That means what we just did is we drew the inverse. And so when I slide this over to here, and I fit it between 1 and negative 1, like that, I have sine x here, inverse sine of x. I'll give you a chance to draw it. Only problem is I goofed. That's not a function, is it? So we got to do some erasing. So I'm going to take a little of this off, a little off the top, like a haircut. Take a little more. Is it a function yet? Vertical line test? No. Is it yet? No. So I got to kind of keep shaving a little bit off here and there until I get to about there and there. And this is pi over 2, and this is negative pi over 2. This is the graph of inverse sine. Is it a function? Yeah. So this is exactly why you couldn't get a number in the domain less than negative 1 and greater than 1, and in the range you couldn't get anything smaller than negative 90 degrees or larger than 90 degrees. I was a little protective of my money in that example. You're not going to get larger than 100, are you? That's inverse sine. And I just wanted to show you why when you take inverse sine that you don't get any number that exists. You're restricted because this has to be a function. Let's try cosine, okay? Cheap. So proving my frugality again, if you draw the cosine curve, looks like this. Okay, and if I take this and turn it and flip it, oops, rats. I sometimes do that. Flip it around. It's got to be up and down. And now do you kind of see it should be, oh, this drawing isn't perfect. There, do you kind of see a little bit of symmetry this time? About like that? Not too bad. And so this one is my inverse, right? And not a function, so we have to do some erasing again. And this one, to make it a function, I'm going to erase all of the negatives. And this one up to about here. Our domain is still negative 1 to 1, so that didn't change. But what's interesting about this one is you're going to go from 0 up to pi. 0 to pi, or 180. Take your calculators, go inverse cosine of 0.999999999. What's the biggest thing that you can get? Inverse cosine of 0.99999 is what? about 180, isn't it? About 180. So that's inverse cosine. You'll never get any negatives, and you'll never get larger than 180. Now, one of the things that's annoying about both of these is you can only put in numbers between 1 and negative 1. What if you can put in any number you want? Now, take your calculator and put in any number inverse tangent, any number. What do you never get bigger than? What do you never get larger than? Do you see it? What's the largest angle you can get? What's that? 90, yeah. This started out from pi over 2, negative pi over 2 to pi over 2. So this domain is negative pi over 2 to pi over 2. And the range is going to be interesting. You can go down from negative infinity up to infinity. So we call that all the real numbers. Now, if I were to take this, turn it 90 degrees, and flip it up and down, you're going to see that real nice symmetry again. That one looks very symmetrical, and it looks like it's going to, whoops, looks like it's going to be about like that. And we've got ourselves an inverse. So this one, being an inverse, is interesting because you can have a domain from negative infinity to infinity, or what we would call all reals. But the range is very cool because you've got a couple asymptotes here at pi over 2 and negative pi over 2. So my range is negative pi over 2 to pi over 2, or negative 90 to 90. When you did inverse tangent of any number, did you ever get bigger than 90? Or less than negative 90? No. So that's the inverse trig. When you use your calculator, come back to these slides so that you know why you never get certain angles, because it's kind of helpful. It's all because you retain a function, you're going to restrict the ranges. All right, well, let's talk about what all of this means anyway. This is the most important part of the day. When I take the tangent of x equal to 1, x is what we call an angle, and 1 is what we call a ratio of sides, coordinates, whatever. So if you take the inverse of tangent to both sides, now you're going to get the inverse tangent of the tangent of x, which is x, and that'll be equal to the inverse tangent of 1. So what we're doing here is 1 is still a ratio, and x is still an angle. So if I take the inverse tangent of a ratio, I'm going to get an angle. So what, right? The one thing you might be bugged by is this arc and inverse. So let me just straighten that out right now. Is if I take the cosine of 60 on the unit circle, here's where 60 is. The coordinate is 1/2 square root of 3 over 2. The cosine of that is 1/2, right? What's the cosine of pi over 3? Still 1/2, right? So if the cosine is 1/2, cosine of 60 is 1/2, cosine of pi over 3 of 1/2, what's the inverse cosine of 1/2? Which one is it? Is it pi over 3 or 60? And the answer is I can't tell unless you look at this. Anytime you see arc, that means the answer is going to be in radians. Anytime you see inverse, we're going to say it's in degrees. Okay? So whenever you see the inverse, it's going to be radian, or inverse is degrees, arc arc length radians. That kind of makes sense, doesn't it? Because otherwise it'd be, how would you tell inverse cosine of 1/2? It's either 60 or pi over 3. The arc tells you it's pi over 3. All right, here's where it gets good. You ready? What if we did a composition where we did an inverse and a function? So here we're taking a ratio and we're converting it into arc radian, right? Or angle. But now we're taking the cosine of it. So you took the ratio, you turned it into an angle. Now you're going to take the angle and turn it back into a what? Cosine of an angle is a ratio. So this is what they call a composition, and you're going to use a clever way of figuring this out. Every time you see inverse in parentheses, I want you to make a triangle. Yeah, so we make a triangle, and then I put sine tells us we can take this ratio 3/5. We can complete it. 25 minus 9 is 16. Square root of 16 is 4. So this part is the make a triangle part. Okay? Now, this part tells you what to do with the triangle. Cosine of theta is 4/5. Done. There you go. All because you learned a song. Okay. Let's try another one. Go down to this one here. Sine of cosine inverse of 4/7. This is, you have this inverse, it means you can make a triangle. So you make the triangle. Cosine, just a second, 4/7. 49 minus 16 is 33, square root of 33. What is the sine of this triangle? Square root of 33 over 7. Yep. All right, so for tomorrow, go down to the day one. Do those day ones. I am checking them tomorrow, so make sure you do all day ones that are circled. Have a great day.